When we're trying to find angle measures within a triangle, it's always a good idea to keep a few things in mind. One of those things is that a triangle consists of three angles that add up to 180 degrees. The other thing to keep in mind is that if we had a straight line and that straight line consisted of two angles, like this, where one angle is here and the other is there, then these two angles also add up to 180 degrees. These two angles are technically called supplementary angles, but for the sake of this lesson, we're just going to say that if two angles make a straight line, just like these two, then those two angles add up to 180 degrees. The third concept we want to keep in mind is anytime we have two lines that intersect, which means they kind of make an X sort of shape, then the angles on opposite sides are always equivalent. In other words, this angle up here is exactly the same as the angle measured at the bottom. Just as an example, if this angle was given to us, and if this angle was something like 40 degrees, that means that this other angle on the opposite side of it would also be 40 degrees. Similarly, the angles on the left and right would also be equal to each other. So in this case, let's say that this angle is 140 degrees. If this angle on the left is 140 degrees, then that means that this angle on the right has to be 140 degrees. These are technically called vertical angles, and these vertical angles are equal to each other. With these three concepts, we should be able to solve the remaining problems in this lesson. So just to briefly repeat myself, when we have a triangle, it consists of three angles, and those three angles add up to 180 degrees. When we have a straight line, and that straight line is split up into two angles, it doesn't matter how those angles look. Those two angles added together are going to give us 180 degrees. And the last concept, vertical angles, is that if we have an intersection of two lines, it doesn't matter how they intersect, they can intersect like this too. Then they form angles that are equal to each other, and those angles are always on opposite sides. So if this is 30 degrees, this would be 30 degrees. This was 150 degrees over here, then that means that this angle at the bottom left would be 150 degrees. With those concepts in mind, let's look at this problem. So if we look at this problem, we'll notice that we have a triangle in the center, but we have these angles on the outside of the triangle. My main goal is to have angles within the triangle. We don't want to deal with angles that are outside of the triangle. So if we focus on one of those angles, let's say we focus on this 57, I want to use that 57 to figure out what angle is inside of here. If we think about this figure and we compare it to one of these concepts, we'll notice that there are two lines that intersect. Because we have those two intersecting lines, it forms what we call vertical angles, which is this last concept that I went over. So if this angle on the bottom left of the triangle is 57 degrees, right across from it, we're also going to get an angle of 57 degrees. So in terms of this triangle, we filled out one of those angles. We know that this bottom left angle is 57 degrees. And at this point, I can ignore this 57 that's written on the outside of the triangle. So I have an X inside the triangle, I have 57. And now I need to figure out what this angle is right here. So to do that, we need to look at the 116 degrees. If we only zoom in to that figure, to this circled section, we'll notice that we have a line that runs from left to right, and it looks like this with 116 degrees right here. I'm ignoring the small section that goes out to the bottom right because we don't need this part. All we need to keep in mind is that this line runs from left to right and then it's split up into two angles, 116 degrees and this angle that we're looking for. If we compare what we have to one of these figures, we'll notice that it matches up with the center idea, which is supplementary angles. So two angles that make a straight line add up to 180 degrees. That means that these two angles add up to 180 degrees. And that means we can take 180 and subtract it by 116. Whatever this gives me will be the angle that's missing. So if I go ahead and do the subtraction, we do 0 minus 6, which we can't do, so we change the 8 to a 7 and turn that 0 into a 10. So 10 minus 6 becomes a 4, 7 minus 1 becomes a 6, 1 minus 1 gives us a 0. So we're left with an angle of 64 degrees. So this angle inside the triangle is actually a 64 degrees. If we look at our triangle, we kind of have all of the angles now. We have a 57 on the bottom left corner, an X on the top, and a 64 at the bottom right corner. If we go back to these concepts again, we'll notice that we're dealing with 3 angles, and those 3 angles add up to 180 degrees. So the next step I want to do is I literally want to add all of these things together. I want to take X, I want to add it to 57, and I want to add it to 64. When I do that, I should end up getting 180 degrees. The next thing I need to do is actually solve this equation. So we can go ahead and combine the 57 and the 64. We can add them together. If we add them together, 7 plus 4 gives me 11, and then 6 plus 5 gives me 11 plus the extra 1 is 12. So I get 121 when I add those two numbers together. To finish solving this equation, to get the x by itself, we do the opposite of whatever is happening to the x. The x is being added to 121, so we're going to subtract 121 from both sides. If I do that, I end up with x equals whatever 180 minus 121 is. And if we do the math, that ends up giving me 59. So we get x equals 59, and that would be our answer. We don't need to put the degree symbol because if we look back up here at this original x, that x already has a degree symbol. So if we replace only the x with the 59, then it'll automatically have that degree symbol carried over. So these problems are a bit involved, but all of them are going to come down to applying each one of these ideas, knowing that a triangle has 180 degrees, knowing that supplementary angles add up to 180 degrees, and knowing that vertical angles are equal to one another. This problem looks a bit complicated, but anytime we're trying to find angle measures of a triangle, we don't want to be dealing with multiple triangles. The reason I say that is on this figure, it seems like we have 2 triangles. The x and the 31 split up those 2 triangles. But what we can do instead is we can treat this as if it was just one triangle. And I'll go ahead and outline that large triangle. Okay, so this is the triangle that we're dealing with, where we have one angle up here, another angle at the bottom left, and then another one on the bottom right. So if we think about what angle is actually up here, this angle would be x plus 31. It would be the combination of x and 31. So that's what we're going to treat that angle as. We're going to treat it as x plus 31. Now that I kind of have this angle on the top, I want to figure out what my other angles are on the bottom left and on the bottom right of this triangle. If we focus on those angles one at a time, on the bottom left we have a 113. We need to look for the angle that's inside of this figure. So if I imagine zooming into this circle, we have a straight line, we have a 113 out here, and then we have this angle inside that we're looking for. If we compare this shape to one of the ideas that I mentioned earlier, we know that these are supplementary. In other words, they end up adding up to 180 degrees. So if they add up to 180 degrees, we can take 180 degrees and subtract it by 113. 0 minus 3 we can't do, so we change this 8 into a 7. 0 becomes a 10. 10 minus 3 gives us 7. 7 minus 1 gives me 6. And we're left with 67 degrees. So it turns out that this missing angle is 67 degrees. And that's what we can write up here. Now that we've figured out this angle, we can go ahead and ignore that 113. So now we have 2 angles of this triangle. We have the top angle, the angle on the bottom left, and now we need the angle on the bottom right. So I want to look at this shape here. We have 2 lines. We have a line that goes down and to the right, and we have another line that goes left and to the right. There's a 38-degree angle on the bottom right. If we compare this to the ideas that I have off to the right, we'll notice that this 38 degrees has a vertical angle. It has an angle opposite to it. And that would be this angle right here. So we know that these two angles would be exactly the same. They have to be equal to each other. We go back to the original image. This is a 38-degree angle inside of the triangle. Just like this other number, we can ignore that 38 degrees and only focus on the one that we rewrote inside the triangle. So we're approaching the end, and what we notice is that we have three angles. We have x plus 31, which we're treating as one angle. We have 67, and we have 38. Altogether, they are going to add up to 180 degrees because they make up a triangle. So that's one of the last steps in the problem, is literally adding up all of these numbers. To make the equation a little easier to work with, we're going to start off with the x first, and then write the rest of these numbers in whatever order you want. So we have x plus 31, so I'm going to go ahead and put plus 31. Then I'm going to add 67, and I'm going to add 38. When we add all of these numbers together, they should be equal to 180, because that's the properties of a triangle. All of the angles add up to 180. Now that we have our equation set up, we can go ahead and combine all of these numbers. So we can do 31 plus 67 plus 38. I don't believe you're allowed to use a calculator for this lesson. I could be wrong, but I don't think you can. So I'm going to go ahead and write them out like this and add them together. 1 plus 7 gives us 8, plus 8 gives me 16. 3 plus 1 gives me 4, plus 6 gives me 10, plus 3 gives me 13. So we get 136. So the x stays the same, but all of these numbers become 136, and this is equal to 180 degrees. Our last step to get x by itself is to subtract 138 or 136 from both sides. That way the x is left by itself. So these go away, and this leaves us with x equals whatever 180 minus 136 is. Since I don't have a calculator, we need to subtract them by hand. 0 minus 6 we can't do, so we borrow a 1 from the tens place, in this case from the 8, and that turns into a 7, and our 0 becomes a 10. 10 minus 6 gives us 4, 7 minus 3 gives me 4, and 1 minus 1 gives me 0. So we're left with x equals 44 degrees. But because we already have a degree symbol written out here originally, we're just going to write x equals 44, and that'll be our final answer. This problem wants us to solve for x. So if we analyze what's going on first, notice that in this triangle itself, we actually have a 57 degrees. But we don't have these other missing angles, so our first step is to identify what those angles would be. If we focus on the bottom left corner of this triangle first, we can figure out what this is pretty easily. It doesn't necessarily need to be equal to a number, but if we look at what's going on, we have two lines. We have these two lines, and we have an x on the bottom left. So if we go back to our ideas over here, we'll notice that this x has a vertical angle. The vertical angle, or the angle across from this x, would be over here, which means that this angle is also equal to x. What that allows us to do is literally copy down this x inside the triangle, and we can ignore the x that was written on the outside. So again, our goal is to figure out what all of these angles are within the actual triangle. So we have an x on the bottom left, we have a 57 at the top. Now we need to find this bottom right corner. If I circle this, imagine zooming into this section. What we end up having is a line going to the bottom right and a line going to the right. We have a 97 over here, and we're trying to figure out what angle is right here to the left of the 97. So we can ignore this extra section that goes down, and we can just focus on these two angles, the missing angle of the 97 degrees. These two angles end up sharing this bottom line. So if we go back to the ideas in the notes, these two angles are supplementary, which means they add up to 180 degrees. So what we can do is we can subtract this 97 from 180. So 180 minus 97. And if we work this out, We can't do 0 minus 7, so we borrow 1 from the 8. That becomes a 7. A 0 becomes a 10, and 10 minus 7 is a 3. If we try doing 7 minus 9, we can't do that, so we borrow 1's place from the next value. This 1 becomes a 0, and the 7 becomes a 17. 17 minus 9 becomes 8. So we end up with an angle of 83 degrees. So that's the angle that's going to be inside of this triangle. 83 degrees. At this point, we have everything needed to set up our final equation. We have 3 angles in the triangle, and we know that they should add up to 180 degrees. So that's what we're going to write down. X plus 57 plus 83 equals 180 degrees. So I can go ahead and combine these two numbers on the left. 57 plus 83. 7 plus 3 would give us 10, so we get a 0. And then 8 plus 5, or 5 plus 8, gives me 13. Plus that extra 1 gives me 14, so we end up getting 140. So we have x plus 140 equals 180. To get the x by itself, we need to get rid of this 140, so we end up subtracting it so that it cancels out. What we do to one side, we do to the other. So we subtract 40 from the right-hand side, and this leaves me with x equals 40 degrees. Since the x already has a degree symbol on it, we just write it as x equals 40. So just like the previous problems, we have a triangle, but it's actually 2 triangles in one. What I want to do first is combine these 2 angles. So I only want to focus on this triangle that covers up the other 2 triangles. So I'm going to treat this angle at the top of the triangle as 43 plus 38. If we wanted to, we could go ahead and combine those to become 81, but for now I'm going to leave them alone. Just like our previous problems, we want to find all of the angles that make up this large triangle. We have the top corner, now we need the bottom left and the bottom right. It doesn't matter which one you start with first, but I would usually start on the bottom left corner, and that's just personal preference. So if I look at what's going on the bottom left, you'll notice that we have this type of figure going on, where we have a 40 degrees on the bottom left corner. If we have a 40 degrees on the bottom left and we use our notes to figure out what's going on, we'll notice that this has a vertical angle. In other words, there's an angle on the opposite side of this 40 degrees that is also 40 degrees. So we can go up in the triangle and put a 40-degree angle inside of it. We can go ahead and ignore this 40 that is on the outside of the triangle. Moving on to the bottom right corner, if I kind of redraw what's happening, this is what we have, and we have an X at the top right. We're trying to figure out what angle is inside the triangle. So we're trying to figure out what angle is right next to this X. Because this angle is right next to the X, we can ignore this bottom section of the line and we can focus on it like this. That'll make it easier to tell that these 2 angles are supplementary. They both share this line that runs through the bottom. So at this point, what we would normally do is we would take this idea of supplementary angles to figure out what these 2 angles are. Problem is, we don't know what either of these are to begin with. We don't know what X is, and we don't know what this question mark is. All we know is that they add up to 180 degrees. So there are a few different approaches to solve the problem, but I think the easiest way to do it would be to figure out what this question mark is first. Because if we look at this triangle, we have enough information to figure out what it is. We know the bottom left corner of the triangle is 40. We know the top corner of the triangle is whatever 43 plus 38 is. And we know that if we add them all up, they give us 180 degrees. So to keep the math simple, that's what we're going to do first. We're going to put this off, so I'll go ahead and circle it so we can get back to it in a second. And what I want to do next is figure out what that question mark is. So I'm going to take all of our angles and I'm going to add them up and set them equal to 180. So that means I'm taking 40 degrees. Actually, let's start off with the question mark first, just because it's unknown. we're going to add the question mark, which I'm going to go ahead and leave it as a question mark, and add it to 40 degrees, add it to 43, and add it to 38. When we add up all of these angles within the triangle, this gives me 180 degrees. At this point, it's exactly like solving an equation. We don't necessarily have an x, we have a question mark, but that's okay. We can leave it as it is. So our next step would be to combine these numbers. 40 plus 43 gives me 83, plus 38 would give me 121. So our equation becomes question mark plus 121 is equal to 180. I'm trying to figure out what this question mark is, so I need to subtract that 121. And if I do that from both sides, we end up getting, we got to do the subtraction, so we borrow 1 from the 8. 10 minus 1 gives me 9. 7 minus 2 gives me 5. We end up getting that this question mark is equal to 59 degrees. For the other problems, this would be my answer, but the problem is this isn't the same as x. So what I need to do is I need to go up here where I have these two question marks, and I'm going to go ahead and replace them with the number that we just found, 59. So I'm replacing these two things with 59 degrees. Our goal for the problem is to solve for x. So now we need to go back to what I had originally circled. We have two angles that are next to each other, and we know that they add up to 180. Now that we know that this question mark is 59 degrees, we can take 180 and subtract it by 59. If I do that, we end up getting 1, 2, 1. We end up getting 121 degrees. So that means that this x is actually equal to 121 degrees. The way you would check that is if you add 121 to 59, you should get 180, which is why we subtracted it in the first place. So we end up getting x equals 121 degrees, and that would be our answer. I believe this is as complicated as these problems get, but just keep in mind that these three ideas, the idea that a triangle has three angles that add up to 180 degrees, supplementary angles share a same side and they also add up to 180 degrees, and anytime you have vertical angles or angles across from each other, they're always going to be equal to each other. With these three ideas, you should be able to solve all of these problems that are given to you.